Every developer knows the friction of juggling an IDE, a chat window, and a terminal. Grok Build attacks this by putting the AI agent directly in your terminal. It's a full-screen TUI, a headless mode for scripts, and an editor integration, all built on a surprisingly layered Rust architecture. This isn't a thin wrapper around an LLM API. It's a full agent runtime with its own control plane, data plane, and observability stack. Let's look inside. So what exactly is Grok Build? It's a terminal-based AI coding agent. It runs as a full-screen TUI, understands your code base, edits files, executes shell commands, and searches the web. It can also run headlessly for scripting and CI, or be embedded in editors via the Agent Client Protocol. It's not a cloud IDE. It's local and terminal first. It talks to XAI's models over HTTP, but does all its work on your machine. Top to bottom, the stack looks like this. Zygrok Pager bin holds composition root, builds the Zygrok Pager binary, and launches the TUI. Zygrok Pager holds TUI, scroll back, prompt, modals, rendering. Zygrok Shell holds agent runtime. Session actor processes prompts, calls sampler, decides tool calls. Zygrok Sampler holds LLM response generation, sampling. Here is the path the data takes. Client ACP request. A client sends an ACP JSON RPC request over a Unix socket to the leader process. Then leader multiplexing. The leader rewrites request IDs with a client ID prefix and routes session/load replays only to the loading client. It broadcasts machine-wide notifications to all clients. Then bridge to ACP channel. In the pager, bridge_leader_connection converts the leader's raw JSON string channels into an ACP client channel via bridge_channels, which spawns a thread running a local set that wires client-side connection for JSON RPC ser/dser. Then outbound line forwarding. The writer task reads lines from the outgoing simplex pipe and calls forward_outbound_line to send them to the leader. On send failure, the line is held, blocking later lines, until a reconnect swap installs a fresh TX, then dropped as dropped stale, never replayed. Then workspace dispatch, workspace ops. Dispatch either calls op execute, handle, session_ID, directly in local mode, or serializes the op and routes through the server RPC in proxy mode. Then tool call dispatch, workspace ops. Call_tool in local mode dispatches through the workspace session's finalized toolset. In proxy mode, it checks the client is connected, then calls the remote tool harness and consumes the stream terminal. Who calls whom? Zygrok Pager bin calls Zygrok Pager over binary launch, composition root builds, and starts the TUI. Zygrok Pager calls Zygrok Shell over ACP message, agent client protocol. Zygrok Shell calls Zygrok Sampler over direct call, session actor requests LLM responses. Zygrok Shell calls Zygrok Tools over tool dispatch, based on model decisions. Continuing the call chain. The decision points along the way. Leader mode resolution. Resolve_leader_mode decides whether to use a leader based on CLI flags, config, remote settings, and sandbox profile. Resolve_leader is used for workspace commands. Then workspace gate. Workspace_command_gate resolves workspace_command env override versus remote workspace_command_enabled flag. Unknown, settings not loaded, fails closed with a network error. Then readiness gating. Run_leader_server gates ACP, forwarding on ready_rx. While false, requests get a leader_starting error and notifications are dropped. Then request ID namespacing. Rewrite_request_ID prefixes each client request ID with the client ID and a pipe separator. Parse_response_ID restores the original ID when routing responses back. Then session routing. The leader tracks session_driver and session_subscribers. Notifications fan out to subscribers. Reverse requests go to the driver, and child sessions are routed to the parent subscribers. Then replay after reconnect. The stio bridge caches initialize and session/load requests. On leader reconnect, it replays them sequentially, waiting for each response before declaring the session restored. The project is organized as a Rust workspace with 5 functional layers. The entry point layer holds the TUI and the binary that ties everything together. The control plane is dominated by the agent runtime and leader process. The data plane contains the tool implementations, the workspace abstraction, and the sampler that calls XAI's APIs. Below that, storage and infrastructure handle persistent state. And observability and security wrap the whole thing with telemetry and sandboxing. The key architectural decision is the leader-client model. A single leader process multiplexes multiple clients, like the TUI, headless scripts, and editor plugins, over one agent. This uses the agent-client protocol over Unix sockets. A request flows from a client to the leader, which rewrites the request ID with a client prefix. Then it routes to the session actor, which dispatches to the workspace, and finally to the tools. This lets you run a TUI session and a CI job against the same agent state. Grok Build solves real problems with a set of key features. The full-screen TUI keeps your coding session inside one terminal window. Headless mode makes the agent scriptable from CI pipelines. The agent client protocol provides a standard interface for editor integration. Web search and fetch give the agent current information. Codebase indexing uses TreeSitter for fast code navigation. And sandboxing contains agent actions at the OS level. To get started, you can build the TUI from source with cargo run, or install the release binary with the install script. Both land on the same Grok command. The first command compiles and launches the full-screen TUI. The second downloads a pre-built executable. From there, you can also run Grok with the -p flag for a single headless prompt, or Grok agent for a scriptable session. Where does Grok Build shine? It's a strong fit for local bug fixing. You can ask it to diagnose a failing test, inspect code, apply a patch, and run tests again, all in the TUI. Headless mode is great for CI pipelines, generating code changes, or running automated review. But the fit is partial if you want to use non-XAI models. The agent is tightly integrated with XAI's APIs. Network file systems also have partial support, with some latency issues. How does Grok Build compare to other terminal agents? All three tools occupy the same niche. They edit files and run commands. The key difference is the model provider. Grok Build uses XAI models, Codex uses OpenAI, and Claude Code uses Anthropic. The main advantage for Grok Build is its deep workspace integration. The main drawback is vendor lock-in. Language and license also differ. Grok Build and Codex are Rust and Apache licensed, while Claude Code is TypeScript and proprietary. Grok Build is a production-grade Rust workspace that shows how to build a terminal AI coding agent. Its leader-client architecture, channel-based actors, and file system-aware journaling are all worth studying. The project is open source under Apache 2.0. You can find it at github.com/xyorg/grokbuild. The codebase is large, so target specific crates when exploring. Thanks for watching.